Good day, everyone. Welcome to Basic Calculus. Originally, calculus is called the infinitesimal calculus because it deals about infinities. But here in Basic Calculus, we will discuss about finite things. Calculus is the mathematics of change. Now we will start at the topic about the limits or the limit of a function. Consider a function f of a single variable x. Consider a constant c which the variable x will approach c or may not be in the domain of f. The limit to be denoted by L is the unique real value that f of x will approach as x approaches c. So this is the notation, limit of f of x as x approaches L. Okay, so let's start for the first example. Consider the limit of 1 plus 3x as x approaches 2. So the f of x here is 1 plus 3x, or our function. So f of x is equal to 1 plus 3x, while the c is equal to 2. In this lesson, we will identify the limit of a function by looking at the table of values. So let's construct a table of values. Actually, there are two tables of values to be constructed, the left side and the right side. So here at the left side, we will assign the values of x, which is lesser than the value of c. So the c here is 2. Take note, we will assign the values of x, which is lesser than 2, but close to 2. Make sure that you assign values of x here in ascending order. Next is you will assign the values of x at the right side. So we will assign the values of x here, which is greater than the value of c, which is 2, but closer to 2. So in this part, x is greater than c, but close to c, or 2. Here we will assign x in descending order, approaching to the value of 2. And then we will get its value in f of x. So 1 plus 3 times 1, that's 4. 1 plus 3x, or 3 times 1.4, that's 5.2, and so on until to the last value. So 1 plus 3 times 1.9999999 is equal to 6.9999997. So this is the equivalent f of x. At the right side, we will also get the value of f of x. So with the same function, 1 plus 3x, we will substitute the value of 3 to our x. So 1 plus 3 times 3 is equal to 10. 1 plus 3 times 2.5, that's 8.5, until the same process goes on until this one. 1 plus 3 times the value of 2.0000001 is equal to 7.000003. Okay, let's observe the limit of the function. So let's start with the left side. So as x approaches to the value of c, which is 2, we could see here in the left side table that the f of x approaches to what value? 7. In the same way, here at the right side, as the x approaches to the value of c, which is 2, the f of x approaches to the value of 7. Therefore, the limit of the function is 7. So again, the limit of the function is 7. As the values of x get closer and closer to the value of 2, the values of f of x get closer to 7. So therefore, the limit of 1 plus 3x as x approaches 2 is equal to 7. So another example, we will investigate the limit of x squared plus 1 as x approaches to negative 1. So here, the f of x is x squared plus 1 and the value of c is negative 1. So in the same process, we will construct a table of values in the left side and the right side. So the left side, we will assign values of x which is lesser than the value of c. Take note, the c is negative 1. So we will assign values of x which is lesser than negative 1 in but close to c or close to negative 1 in ascending order. So we could assign any values. So for this, I assign negative 1.5, negative 1.2, negative 1.01, and negative 1.0001. Here at the right side, we will also construct a table of value which the x is greater than the value of negative 1 but close to negative 1. This time in descending order or decreasing order. So I assign here negative 0.5, negative 0.8, and negative 0.99, and negative 0.9999. Then let's take the value of f of x using the function. Okay, so x squared or negative 1.5 squared plus 1, that's 3.25. Negative 1.2 squared plus 1, that's 2.44. The same process here and also here. At the right side, the f of x of negative 0.5, so negative 0.5 squared plus 1, that's 1.25. Same process to get the f of x using these values here sa atong x till this 1. Okay, so let's determine the limit of the function. Okay, so as the x values get closer and closer to the value of negative 1 or our c, the f of x approaches to the value of 2. In our right side table, as x approaches to negative 1, the value of f of x approaches to the value of 2. Therefore, as the values of x get closer and closer to negative 1, the values of f of x get closer to 2. Thus, the limit of x squared plus 1 as x approaches negative 1 is equal to 2. Let's have another example. We will investigate the limit of x squared minus 5x plus 4 all over x minus 1 as x approaches 1. Our function or f of x is equal to x squared minus 5x plus 4 all over x minus 1, while the value of c is 1. Again, we will construct a table of values in the left side and the right side. The left side will be the values of x is lesser than the value of c but closer to c in ascending order. So here I assign 0.5, 0.88, 0.996, 0.9999. At the right side, we will assign values of x which is greater than the value of c, which is 1, but close to it. Okay, so I assign here 1.5, 1.17, 1.003, 1.0001 in descending order. Okay, so let's get the value of f of x. So using this equation or the function x squared minus 5x plus 4 all over x minus 1, we will substitute 0.5 in all values of x. That's our result is negative 3.5. Next is 0.88. The result is negative 3.12, and so on. Here at the right side, we will get the value of f of x using the x value here. to substitute in the